Now this we talked about at the beginning of class. When we were asking you guys, what did you learn from your reading? And just like each one of you guys learns at a different rate, every type of mineral melts at a different rate. They all melt at different temperatures. And that's what we call partial melting. And that's basically all you guys need to know. Now that process is the key concept behind the smelting process.
Smelting?
Yeah, smelting. What is smelting?
It sounds like it's like smothering and melting.
Yeah, kind of. What is smelting?
You're like high pressure.
Oh, it does actually.
And melting at the same time.
Yeah. But it's not what they call smelting. All right, what do I have in my hands?
A rock.
What type of rock?
Big rock.
Rock
And then
has cleavage.
And extrudes.
It does look like it's cleavage, but it's definitely more fraction than cleavage.
I don't see it.
But I can see where you might have said cleavage. It's iron ore. What does that mean?
It's heavy. It's pure iron.
Does it mean pure iron?
No. No.
So iron's in here.
Yes.
What does that actually mean to say that there's iron in the rock?
It's melting again.
Yeah, like I can't just break the rock open and there's my iron, right? It's not a meteor, right? The iron is chemically bonded to other minerals inside the rock, but there's large amounts of that iron in here. So all I have to do, ladies, is figure out a way to break those bonds, and that's called smelting. And in the smelting process, they take giant chunks like this, and they grind it up into fine powder, and then they melt down the powder. Now, why would they do that?
It's pure stuff.
Yeah, because as that powder's melting, the other chemicals will probably either melt first or melt later. All right, and if you're one of these companies that does it, and they know exactly when the iron is going to melt out,
Yeah.
and then they literally just skim off the other stuff, and then you're left with pure iron. And they do this 2 or 3 rounds. By the time you're done, you're left with like a 99% iron content. And that's literally, so it starts off with just rock like this. And then just by basically pounding it into dust and then melting it off, we can separate the chemicals that make up that ore and get the iron. That's basically how they do it. So that's partial melting. It's kind of using that process. Now the reverse of that is fractional crystallization, which you guys have seen in the geode that was passed around as well as in this one. And in fractional crystallization, we go in the reverse order of partial melting, where the minerals with the highest melting point crystallize first, because they're the first ones to cool off. Let's think about it. If I have let's say we're at 2,000 degrees Celsius. And we need to get all the way down here, let's say to 500 degrees Celsius. And I've got mineral A, B, C, and D. And mineral A, let's say its melting temperature is 1,800 degrees Celsius, B is 1,500 degrees, C is, let's say, 1,000 degrees, and D is, let's say, 650 degrees Celsius. Okay, so here we go. We got this pool of magma that's 2,000 degrees Celsius, and it starts to cool. So think about it. It's literally this moving bar. And as that temperature starts to drop, what happens as soon as I get below 1,800 degrees? What does the A start to do? It starts to cool and therefore crystallizes. So we get crystals of A. Whatever that material is. And then everything underneath that is all still molten, right? Because their temperature is too high for this other stuff to crystallize. So it's all still molten. So you get that layer of mineral A surrounding the outside of the geode. As that temperature drops below 1,500, what's our next layer going to be? We get crystals of B. And so that's fractional crystallization. And you typically have these layers of crystals that start to take place. You can see that in the geodes that have been passed around. Each one of those layers is a different mineral that has cooled and crystallized at different temperatures. Let's see where I did that. Okay, so we've already talked about that. And don't really need to do journals. So, okay, we're done.